Hello everyone, this is again Teacher Jenny guiding you on the fourth module for quarter 3 of Statistics and Research 8 with the topic, the true mode of grouped data. At the end of this video, you are expected to know when to use the true mode of a grouped data and calculate the true mode of grouped data. Last time, we discussed on how to find for the mode of grouped data. And in order for us to solve for it, we have to identify or look for the modal class. Now, can you still remember how to find for the modal class of a given grouped data? Very good. It is simply the class containing the highest frequency. Now, what if we have a grouped data with two or more class intervals with the highest frequency, like this? Can we still use the mode of grouped data we discussed last time? You're absolutely right, because the mode we discussed last time is known as the crude mode. If you can still remember, when we say mode, it is the value that appears most often in a given set of data. In other words, it is the value with the highest frequency. This is known as the crude mode. But this is only applicable in approximating the mode of a data with only one mode, or also known as unimodal. Now, in cases wherein a given data is multimodal, the true mode should be used to address the problem of not having only one modal class. This mode does not literally consider the frequency of the data alone, but makes use of the other two measures of central tendency, which are the mean and the median. Formula, we have mode is equal to 3 times the median minus 2 times the mean. Let us have examples. First, find the true mode of the given frequency distribution. So as you can see here, the table is already ready for all the needed information to solve for the true mode of the given grouped data. So first, let's find for the class size. What's the class size of the given data? Very good. We have 2 because there are 2 numbers included in each class interval. How about the summation of F, or the total frequency? You're right, it's 70. We simply have to add all the numbers under the frequency column. Now let's proceed to the class mark. If you can still remember, the class mark is found by adding the upper limit and lower limit divided by 2. So for the first class mark, we have 1 plus 2, that's 3, divided by 2, so we have 1.5. Now for the class interval 3 to 4, we have 3 plus 4, that's 7, divided by 2 is 3.5. Now to find for the succeeding class marks, it would be easier if you... Now, to find for the succeeding class marks, it would be easier if you use the class size. So we simply have to add the class size to the preceding class mark. So to find for the class mark of the class interval 5 to 6, we have 3.5 plus 2, that's 5.5. For the next class interval, we have 5.5 plus 2, that's 7.5. Plus 2 is 9.5. Add 2 again, we have 11.5, followed by 13.5, 15.5, 17.5, and of course, we have 19.5. Now, for the fx column, we simply have to multiply the frequency by the class mark. So, for the class interval 1 to 2, we have 2 times 1.5, that is 3. Next, 9 times 3.5, that is 31.5. 5 times 5.5, that is 27.5. 12 times 7.5, it's 90. 8 times 9.5, that's 76. 7 times 11.5 is 80.5. 12 times 13.5 is 162. 15.5 times 6 is 93. 17.5 times 8 is 140. And 1 times 19.5 is 19.5. Now, since we have found all the values of the fx column, we can now add to find for the summation of fx. So the sum of all the fx values is 723. Now, to find for the mean of the given grouped data, we have to use the formula mean is equal to summation of fx all over summation of f. By substitution, summation of fx is 723 and summation of f is 70. Dividing 723 by 70, that gives us 10.33. So the mean of the given grouped data is 10.33. Now let's have the LB column or the lower boundary column. Take note, to find for the lower boundary of each class interval, we simply have to subtract the lower limit by 0.5. So for the class interval 1 to 2, we consider the lower limit, it's 1, minus 0.5 is 0.5. For the class interval 3 to 4, the lower limit is 3 minus 0.5. So we have 2.5. Now for the succeeding lower boundary values, we can add 2 to the preceding LB values to find for the succeeding values. So we have 2.5 plus 2, that's 4.5, plus 2 is 6.5, plus 2 is 8.5, plus 2 is 10.5, plus 2 is 12.5, plus 2 is 14.5, plus 2 is 16.5, and of course, we have 18.5. Now, let's have the last column. We have the cumulative frequency. Let's start at the bottom. The cumulative frequency of the lowest class interval should be equal to its respective frequency. So since we have 2 here, then that means the cumulative frequency of this lowest class interval is 2. To find for the succeeding CF values, we have to add the next frequency. So that's 2 plus 9, we have 11. Plus 5 is 16. 16 plus 12, that's 28. 28 plus 8 is 36. 36 plus 7, that's 43. 43 plus 12, that's 55. Plus 6 is 61. Plus 8 is 69. Then plus 1, we have 70. Now, to make sure that your CF values are correct, the CF value of the highest class interval should be the same with the total frequency. And as you can see here, we have same values, then that means our CF values are correct. Now let's find for the median class because we need it to solve for the median. So to find for the median class, we use the formula summation of f all over 2. Summation of f is 70, so that's 70 divided by 2, it's 35. Now looking at the CF values, the smallest number greater than 35 is 36. So the median class is the class containing the CF value, which is 36. So this is our median class. Now, since we've found the median class, we can now solve for the median of the grouped data using the formula median is equal to the lower boundary of the median class plus the quantity summation of f over 2 minus less than cf all over the frequency of the median class times the class size. By substitution, the lower boundary of the median class, it's 8.5 plus summation of f over 2, that is 35, minus less than CF, it's the number below the CF value of the median class. So it's 28 divided by the frequency of the median class, that is 8, times the class size, which is 2. Now, to simplify these, we start from subtracting 35 by 28, and that is 7. 7 times 2, that's 14 divided by 8, so we have 1.75 plus 8.5, so we have 10.25. So again, the median of the given grouped data is 10.25. Now take note that in finding the true mode of a given grouped data, we only need the mean and the median. Now since we already have those values, then we can now substitute to the formula of true mode, which is 3 times the median minus 2 times the mean. By substitution, we now have 3 times 10.25 minus 2 times 10.33. So that is 30.75 minus 20.66. And that gives us 10.09. So the true mode of the given frequency distribution is 10.09. Take note, in solving the mean, the median, or the true mode, if the values are not exact, round off to the nearest hundreds or to 2 decimal places. Let's have another example. Find the true mode of the given frequency distribution. First, we have to identify the class size. And what is the class size of the given data? Very good. We have 6 because there are 6 numbers included in each class interval, or that is taken by subtracting the upper limit by the lower limit plus 1. 8 minus 3, it's 5, plus 1, we have 6. Now, for the summation of f, we simply have to add all the frequency values, and that is equal to 40. Now, what is the class mark of the class interval 3 to 8? Very good. It's 5.5. So we have to add the upper limit and the lower limit, then divide the sum by 2. So 8 plus 3 is 11 divided by 2. So we have 5.5. For the class mark of the next class interval, we simply have to add the class size to the preceding class mark value. So that's 5.5 plus 6, we have 11.5. Plus 6 again, it's 17.5. Add 6 again, it's 23.5, followed by 29.5, then 35.5, then 41.5, and then of course we have 47.5. Now for the fx column, again, you have to multiply the frequency by the class mark. So what is the fx value of the class interval 3 to 8? If your answer is 11, then you are right, because to solve for the fx value, you have to multiply the frequency by the class mark. Followed by 3 times 11.5, that is 34.5, followed by 6 times 17.5, which is equal to 105. 5 times 23.5 is 117.5. 8 times 29.5 is 236. 8 times 35.5 is 284. 7 times 41.5 is 290.5. And 1 times 47.5 is, of course, 47.5. Now, add all those values under the fx column. That will be our summation of fx. It is 1,126. Now, we can already find for the mean of the given grouped data. So to solve for the mean, we use the formula mean is equal to summation of fx all over summation of f. By substitution, we have 1,126 divided by 40, and that gives us 27.7. Now let's proceed to the next column, the lower boundary column. What's the lower boundary of the class interval 3 to 8? That's amazing. We have 2.5. So we simply have to subtract 0.5 from the lower limit. So that's 3 minus 0.5 is 2.5. And then add 6 to find for the lower boundary of the next class interval. So we have 8.5 plus 6 again, that's 14.5. Plus another 6, it's 20.5, then 26.5, then 31.5, then 38.5, and then of course we have 44.5. Now let's have the cumulative frequency column. Let's start from the lowest class interval. We have 3 to 8. Again, it must be the same with the frequency of the given class interval. So that is 2. Add the next frequency to find for the succeeding cumulative frequency values. So we have 2 plus 3, that's 5. 5 plus 6 is 11. Plus 5 is 16. Plus 8 is 24. Plus 8 is 32. Plus 7 is 39. And plus 1 is 40. So take note, we have same values for the cumulative frequency of the highest class interval and the summation of f, or the total frequency. Now let's find for the median class by finding the value of summation of f over 2. So that's 40 divided by 2, so it's equal to 20. Now, on the CF column, find the smallest number greater than 20. What is that number? You're right, it's 24. So the median class is on the class interval 27 to 32 because it contains 24 on the CF column. So since we have found the median class by using the formula, median is equal to the lower boundary of the median class plus summation of f over 2 minus less than CF all over frequency of the median class times the class size. By substitution, the lower boundary of the median class is 26.5. Summation of f over 2, that is 20, it's here, minus less than CF, it's the number under the CF column below the CF value of the median class. So it's 16. All over the frequency of the median class, it's 8 times the class size, which is 6. Simplifying the equation. Now simplify. We start with the difference of 20 and 16. So that is 4 times 6. So we have 24. Divided by 8 is 3. Add 26.5 and 3. That gives us 29.5. So the median of the given frequency distribution is 29.5. Now, since we have our mean and median values, we can now find for the true mode of the given group's data. So we will use the formula mode is equal to 3 times the median minus 2 times the mean. By substitution, we have 3 times 29.5 minus 2 times 27.7. Simplifying, we now have 88.5 minus 55.4. 88 minus 55.4 is 33.1. So the true mode of the given frequency distribution is 33.1. Do you have questions? If you have, kindly type them on the comment section. Now, before we end this video, remember that there are two types of mode of grouped data. First is the crude mode, which is applicable when we want to find for the mode of a grouped data which is unimodal, or there is only one class interval with the highest frequency. But if we have a multimodal, we use the true mode. Take note, the true mode is used to address the problem of not having only one modal class. So this will use the other two measures of central tendency, which are the mean and the median. So the formula of a true mode is equal to 3 times the median minus 2 times the mean. That's all. I hope you have learned a lot from this video. Thank you for watching. Goodbye.